Now we know that what is positively charged and what is negatively charged. Now let's make use of this concept and understand the same example. Say you have a balloon and you rub that balloon on your hair, okay? Now when you rub the balloon, what happens? Flow of electrons takes place because electrons are mobile, right? So there are electrons present in your hair, there are electrons present in the balloon. So electrons flow from hair to balloon. So from your hair, electrons tend to flow into the balloon. So what will happen? Your hair is losing electrons. So the hair is becoming positively charged, right? And the balloon is gaining electrons. So the balloon will become negatively charged because it's gaining a negative charge. So once it's rubbed, this balloon has a net negative charge, right? Now when you take this balloon near a wall or near some other object, there are chances that it will experience a force, right? So this balloon is negatively charged, that is sure, right? Now bring another balloon. Now you are having two balloons, okay? And rub both balloons on your hair first, one by one, okay? Now what happens after rubbing? Similar thing happens. Both the balloons occur negative charge, both becomes negatively charged. Now bring both the balloons near. As soon as you bring both the balloons near, of them have similar charge, that is negative charge. Now when you try to bring the balloons closer, what happens? You will see that the balloons tend to go away from each other. It means they will move away from each other, they will repel. So the balloons repel each other. So that is an interesting observation. So this proves that like charges, that means here negative and negative, or you can say positive positive. So like charges always repel each other. So similar charges, as both the balloons have similar negative charge, so negative negative charge, they will always repel each other. Now do the same experiment with wall. Now bring one of the balloon near the wall. What happens? Balloon will stick to the wall. Why? Because the wall in this case is not negatively charged. The wall as a whole is neutral. The wall is not charged. But when the balloon is brought near the wall, so the balloon is the charged object, right? And the wall is an uncharged object which doesn't carry any charge. So what happens? There's an attraction between the balloon and the wall. So from this observation, we can say that a charged object always tend to attract an uncharged object. So balloon is a charged object, wall is an uncharged object, and this balloon is attracting uncharged object. That means charged object is attracting uncharged object. Now why it attracts an uncharged object? We will see that a little later. So that was the next observation. Okay. Similarly, if you take the same balloon in front of the small bits of paper, we are taking this balloon in near to the small bits of paper. What happens? Paper will also stick to the balloon, right? Again, the papers are not charged, bits of papers are not charged, they are neutral. So whenever a charged body balloon is brought near an uncharged balloon, that are bits of paper here, there is some sort of attraction. So the conclusion was that like charges repel each other, right? This was the first conclusion. That means negative negative charge or positive positive charge will repel each other. Whereas unlike charges, that means positive negative, or you can say negative positive, these unlike charges, they attract each other, they will tend to attract each other. Now what will happen if there is a positive charge or negative charge, and a positive charge or a negative charge, and the other object is neutral? For example, you are having a one object that is either positive charge or negative charge, and the other object is neutral. In that case, you will also see an attraction. Now the question is, how exactly this attraction is happening? Now we will again take the same example and we will try to understand how exactly a positively or negatively charged body attracts an uncharged body. Okay. So let's take the example of these paper bits again and see, these are neutral. They don't have any charge, right? But the balloon is negatively charged, right? Now, as we saw that negative charge will attract positive charge. So what happens here? All these neutral bits of paper, they are having both positive charge as well as negative charge inside them. Now, since the balloon has negative charge, so what happens? All the positive charge in the bits of paper tend to come on this side, this upper side, all the positive charge. And the negative charge will come on this side, on the downside, bottom side. Positive charge will move here. So, on this side, we are left with now, on the upper side, we are left with only positive charge. And as a result, they tend to get attracted with the negative charge, that is with the balloon. In a very similar way, in case of wall, what happens? Wall as such is neutral. It's carrying both positive and negative charge. But what happens when this negatively charged balloon is brought near the wall? All the electrons present in the wall, they tend to move on this side, negative charges, that means electrons. And what are we left with here? We are left with the positive charge, right? So as a result, positive and negative will attract each other. That is why a balloon sticks to the wall. And that is how the attraction between a uncharged body, that is here wall or bits of paper, they get attracted towards a charged body, that is a balloon here. Okay, so overall, what did we learn? We learned that if positive similar charge are brought together, or negative again a similar charge, if they are brought together, they will repel. And if positive negative is brought together, they will attract. If positive neutral is brought together, they will also attract. If negative and neutral is brought together, they will also attract. So this is what we understand about the electric charges so far. So what is electric charge? A force experienced near another electrically charged object. And there are two types of charges, positive and negative. Like charges repel each other and unlike charges attract each other. So now whatever we are talking right now, we are only talking about static charges. The charges that are not moving. They are located on a particular object. See, whenever charges are flowing from one place to another, that constitutes electric current. Flow of electrons is nothing but they are forming electric current, or you can say electricity. So flow of charge is electric current. Now, how exactly is static electricity different from the current electricity? Because there are two types of electricity here, static electricity and the current electricity. Now, how are these two different? Now, when the balloon gets electrically charged, we do not feel any current in the balloon. But when we touch a wire through which current is flowing, we actually feel an electric shock, right? So let's quickly look at the difference between static electricity and current electricity. The word static, it means when something is at rest. So when we talk about static electricity, it arises due to the imbalance of charges. Now, what do we mean by this? That means when an object either has excess of charges or it has less charges. That is imbalance of charges. For example, if when an object acquires additional electrons, it becomes negatively charged. And whenever an object loses out some electrons, it becomes positively charged. And whenever positive and negative charges are not well balanced, we say that the object is electrically charged. So that is in simple terms what we call as static electricity. Now, when we talk about current electricity, we always talk about flow of charges. That means the charges are not at rest. They are not at rest on particular places, but charges are moving from one place to another. So movement of charges is current electricity. Okay, in static electricity, charges are static. That is, charges are at rest. They are not moving anywhere. So when you talk about charged balloon, which has a net negative charge, we saw those extra electrons are just sitting on the balloon. But in current electricity, what happens? Charges flow through a conducting material. So again, we are having good as well as poor conductors of electricity. So if you look at good conductors, they allow electricity to pass through them. That is why they allow the flow of charges through them. So charges keep flowing through that conductor like a metal wire. Now, static electricity is created when when two surfaces, at least one has to be insulator, they contact and then separate. Now, what is insulator here? It's a poor conductor of electricity. Now, why do we need at least one poor conductor for static electricity? Because if all the objects are good conductors, then we will never have static electricity because charges will flow through them. Charges will not remain static. But only when it is a poor conductor, that means charges will not be able to flow through the conductor because that object will not allow charges to flow through them. So, one good example of poor conductor can be plastic. So, it will not allow electric charge to flow through them. So, what will happen to the charges? The extra charges just remain confined in one particular area, and that is how static electricity will be formed. But in case of current electricity, it's created with conductors because those materials which do not allow charges to flow through them, obviously, in those materials, you will not find current electricity. So, here metals are very good conductors of electricity. So, in case of balloon, when it's rubbed with hair, that hair is an insulator. So, you are bringing two surfaces together and then separating them, and that is how the balloon acquires charge. So, the excess charge which came into the balloon is static. That is an example of static electricity, and this is clear now. So, when we are talking about lightning in this lesson, we are actually dealing with static electricity.